This is the last type of function, and this is a new operation that we've not talked about before, the composition function. We've done multiply, add, subtract, divide, but we've never talked about composition before. Composition is used a lot in the world of taxes, coupons, sales tax. When I teach this in class, I tell a story about one time my sister went to eat pizza. She had a coupon for 50% off. And the lady said that everything was already 50% off, so she couldn't use her coupon or she would get the pizza for free. And we know that that's not going to happen in a store, right? If you have 50% off and you get another 50% off, that does not make 100% off. That just wouldn't happen. If it's something's 20% off, an additional 30%, that does not make it 50% off. This concept is always on the ACT at some place. So it's something you want to make sure you get if you're taking the ACT. So a composition function would be something like if you went to the store and you had an item that was $100 to start with. And the clerk told you that everything in the store was 20% off. So if this item was 20% off, now the item would be $80. But then you have an additional coupon for 30% off. So you would do 30% of this number, which really is not going to be the same thing as 20 plus 30. So let's think of what 30% of 80 would be. 70% would be $56. So you can see that what we've done here is we've actually taken 44% off rather than the 20% plus the 30%. So when you go to a store, you have to apply one coupon, get the answer to that coupon, then apply the second coupon. You don't add the 2% together because that's not the same. That's called a composition function. And it's written like this. This kind of looks like a multiplication symbol, but multiply is just a tiny dot. This is the composition symbol. It means of. So I would say f of g of x. So it means that I have to find the answer to g of x and take that answer and plug it into f of x. So let me show you how this works using an actual problem. So here what I've got is I want to find, well, let's just start off finding the domain. First of all, this one is linear. So the domain of f of x is going to be negative infinity to infinity, because if I graphed it, it would look like this. This one's quadratic, so its domain is going to be the same, negative infinity to infinity. So every single one of these is going to start as negative infinity to infinity because the domain of the domain is negative infinity to infinity. And I'll explain what I mean by that. So I want to start by finding f of g of 7. So the input value for the g function is going to be 7. Once I find the answer to this, I'm going to put that as the input value to the f function. So I'm going to go find what g of 7 is. So I'm going to go up here and put 7 in for x. And I'm going to find the answer to that. That would be 49 minus 21 plus 8, which is 36. So now I need to figure out what the f function would be if 36 is the input value. So I'm going to have 2 times 36, subtract 5. So the new function at 7 is 67. Okay, let's find g of f of 7. So this time I'm going to have the g function, and the input value of the g function is going to be the f function at 7. So I'm going to start by putting 7 into the f function. So 2 times 7 is 14 minus 5, which is 9. So now I have g of 9. Now I'm going to put 9 into the g function. So 9 squared minus 3 times 9 plus 8. So h of 7 this time would be 62. Okay, let's do one where we're not really evaluating the entire function at a specific value. We're just evaluating at x. So this time I'm going to have to state a domain because I don't know an input value. I just know the input value is x. So here's how we get the domain of a composition function. I just look at the inside part, the domain of this inside part. So since the inside part is g, I'm going to get the domain of this function by figuring out what the domain of the g function is. And the domain of the g function is negative infinity to infinity. Now, as I work the problem, I may have to tweak it a little bit, but for now, it's going to be negative infinity to infinity. So I'm going to put the g function in for x of the f function. So I'm going to have f of the g function, and the g function is x squared minus 3x plus 8. So this is now the input value for my f function. So I have 2 parentheses minus 5. And in the parentheses, I'm going to put x squared minus 3x plus 8. So the new function that I'm talking about is 2x squared minus 6x, and this would be plus 16 minus 5, so plus 11. This is a quadratic function, no restrictions, so I'm good. Okay, let's look at this last one. This time we're going to have the g function, and in place of the x value, we're going to put the f function. So I'm going to start by putting the f function in here, and the f function is 2x minus 5. So since this is the domain of my new function is going to be the domain of this function, which is negative infinity to infinity. So now I've got to go put this in place of the x in the g function. So I'm going to have x squared minus 3 times x plus 8. And then the place where the x is, I'm going to put 2x minus 5. So this is 2x minus 5 times 2x minus 5. And I'm going to go ahead and multiply that out. Minus 6x plus 15 plus 8. This is going to go to 4x squared minus 20x plus 25 minus 6x plus 15 plus 8. And then when I put my like terms together, I get 4x squared minus 26x plus 48.